We're in 4.7 part 1, and what we have here is a set of examples to get us started on evaluating the inverse trig functions by hand. Now, something that I'll mention throughout these examples as well as ones in the future is that we've got a couple things we want to do. We want to start on any one of these by first of all just determining if the problem can be done. The way we do that is by looking at what's inputted in the function, like 1, negative 1/2, negative square root of 3 over 2, and pi over 2, and we decide, is that within the domain of its particular inverse function? Well, for the first one, tangent inverse of 1, we look at the domain. The domain's negative infinity to infinity. That's no problem there. For sine inverse, negative 1/2, that definitely fits within negative 1 and 1. Cosine inverse, negative square root of 3 over 2. That is also less than 1. It's negative, but it does fit in the domain here. However, number 4 is sine of pi over 2. Now, pi over 2 is approximately equal to 1.57. So if we're doing sine inverse, putting pi over 2 in there will not work. And so this fourth example is not really an example at all. That one will not work out. We can't even plug that in. So what we're going to do with the rest of these, though, is we are going to take a look at the domain. We already did that to see if it worked through it. Then we're going to see what range do we have to come out in. In other words, what quadrants are we going to be using? One thing to remember from the last video is that sine inverse and tangent inverse, we're going to have a range in 1 and 4. Cosine inverse is going to have a range in 1 or 2. And we can decide what that quadrant is going to be for each one of these based on the positive or negative. So for instance, we look at tangent inverse of 1. Since this 1 is positive, and we have to decide is it going to come out in 1 or 4, we know that anything in 1 is, now all those values are positive. 4 has some negative values. So with tangent of 1, tangent inverse of 1, we are just going to use the first quadrant, which means that when we draw this picture, we can draw that picture in the first quadrant. We just now need to fit a special right triangle to give us a tangent of 1. This takes maybe a little bit of guess and check at first, but the nice thing about tangent opposite over adjacent means that the two legs have to be the same dimension. So that is, in this case, square root of 2 over 2 for both of them. And if you've got square root of 2 over 2, that indicates a 45, 45, 90 triangle. Now, the other thing that we have to do here is we have to output these angles in terms of radians. So we're going to, no matter what here today, we are going to use radians as our default for the values of the angles. So a 45-degree angle, if you look on your unit circle, is the same thing as pi over 4. So tangent inverse of 1 is going to be equal to pi over 4. And remember that with inverses, what comes out is the angle. So this makes sense as an answer that we have here. Next one we've got is sine inverse of negative 1/2. Now again, we want to figure out the quadrant. Knowing that sine inverse comes out in either 1 or 4, it's negative, so that means we're going to narrow it down to quadrant 4. So when I draw this picture, I'm going to draw it in quadrant 4. And then the second decision I have to make is which triangle am I talking about? Now the 1/2, that's not anywhere in the 45 triangle, but it is in the 30-60. So I'm going to draw this with a negative 1/2 to it. And this, again, might be a little bit of guess and check, but once you get the hang of it, you'll realize, okay, sine is opposite over hypotenuse. That means that the negative 1/2 has got to go right here. Hypotenuse is right there, and then square root of 3 over 2 is the other side. This is a 30-degree angle if you're looking at the reference angle. And so we've got to output this in terms of radians. Now here's a little bit of a trick on this one. If it's 30 below the axis, you might be inclined to think, since we haven't done a whole lot of these yet, but you might be inclined to think that this is going to be at 11 pi over 6, which you would be mostly correct in saying that. However, notice that for sine inverse, the range is between negative pi over 2 and pi over 2. 11 pi over 6 is definitely outside of that range. So what we need to do instead, when we're talking about these inverse tangent and sine, is we need to think about backing into the fourth quadrant. So instead of going all the way around and going to 11 pi over 6, we're going to back into the fourth quadrant and call it negative pi over 6. That's a little detail that can oftentimes escape us. It's easy to miss if you're not really looking for it. The last one that we'll take a look at here on this example is cosine inverse of negative square root of 3 over 2. Again, first of all, we need to think about the quadrant with cosine inverse. It's either 1 or 2. Since this is negative, there are negative values in quadrant 2, so I'm going to use quadrant 2 in this case. So quadrant 2, we need the cosine to be negative square root of 3 over 2. Well, that's a 30-60 triangle, and if we want that to be square root of 3 over 2, the adjacent side, that's going to make this side right here negative square root of 3 over 2. That's the longer leg, and so the shorter leg up here, we've got 1/2, and then we've got the hypotenuse of 1. The reference angle on this one is 30. 30 is across from the 1/2, but the cosine means that we will be looking at adjacent over hypotenuse, which is the negative square root of 3 over 2. So, like these others, our question always becomes, okay, which angle are we located at? Where are we on the unit circle? That's what we need to be doing in each and every one of these problems. And that's what we've done on those two. So 30 degrees above the x-axis in quadrant 2 is going to be 5 pi over 6. And as you can see from these three examples, we have all of these as being angles that are outputted, and we have picked a quadrant to start. We narrow that down based on positive or negative inside here. And with sine inverse and tangent inverse, we have either 1 or 4. Cosine inverse is either 1 or 2. Once we have the correct quadrant, we pick the right triangle, pick the special right triangle that we're looking for, set up the picture, and then ultimately the answer to the question is, where is this terminal side located? And we've done that for each one of those. So our solutions are like that, and that is where we're starting on just evaluating inverse trig functions. This is what your homework problems will look like, as opposed to all those graphs that we did.